So let's start. About Alliander and me. Alliander is the biggest TSO in the Netherlands. We supply electricity and gas to households and companies. So yeah, we have a lot of kilometers of electricity grid and gas infrastructure. And yeah, we serve a large part of the Netherlands, including the Amsterdam, the big city. So my name is Sander Jansen. I'm product owner at virtual substations team. So I'm looking at the substations in the future, and I'm working at the system operations department. And our department started to get control over the energy flows. I will talk about that later. And my background is in data architecture and electrical engineering. So what are the challenges of the grid today? I think Jose already did a good job in doing so. In our case, yeah, the main issue is that if you want to apply for a grid connection, electricity one, depending on the area where you live, you can see in the map, the red, orange or yellow, the longer you have to wait. So the darker the color of red it is, the longer you have to wait. So sometimes we need to build substations or adding more smaller substations, and then we need permits, etc. We need people to have it. We have all short of technical people in the company. So that leads to yeah, long waiting times, and that's currently holding up the energy transition in our areas for now. Yeah, and that has to do with the same thing as Jose mentioned, changing energy mix, more solar, more wind farm, more electricity production locations. So usually it was the big power plants connected to the TSO, but yeah, we're TSO, so the production gets done in smaller parts of the grid. Higher electricity use, electric vehicle, and like I said before, it's also it's hard to find technical staff today to work on the grid and keep it running. So the main issue is currently grid congestion, and we're looking at yeah, modern ways to solve that, or at least a little bit. One aspect is that we're trying to build new substation and make grid connections. But the other aspects, and that's where the system operations department comes into play, we're trying to see if we can maximize the use of the existing assets. For example, if you have someone that wants to hook up your solar farm to your grid, and yeah, sometimes during the summer there's a peak load, you can say, hey, during the summer we switch you off. Or we say, if you give the electricity during the night, so maybe you organize some storage on that side, then we're happy to have you on the grid. So the idea is that we provide a different kind of contracts or services around existing grid connection. Yeah, and the main reason is that the current grid is not built for this kind of use, and was not built, so we need to convert them to that. And now it's time for the first poll. I think this is the wrong question. And, I had a question about LF energy in mind.
Sorry, Sander, you said the other question on
LF energy, but maybe it's not. I didn't make it through. But then I will continue with my presentation.
All right, I will get it and then we can run it at the end.
Yes. So a little bit about LF energy. So since a couple of years, we as Alliander, we're now official member at the LF Energy Foundation. So the idea behind the Linux Foundation itself, it's a foundation that supports open source software. And the idea behind LF Energy in particular is that we want to build software especially for the energy use cases. A little bit more about the Linux Foundation and Linux itself and open source. Linux itself is, maybe most of you are familiar with that, is one of the world's dominating operating system. It's used with supercomputers, smartphone, in the enterprise side, public clouds, embedded system, and it serves the #1 internet client with Android. And that's all done throughout open collaboration on source code. So everybody with a good idea and some skills can contribute code to the project, and if the maintainers like the code, then it gets submitted. So this open ecosystem allowed us for a lot of innovation and eventually to the adoption of Linux worldwide. And so this open source concept is applied more and more, and you see that it also acts as a market acceleration. So open source allows you to standardize on open source technologies. The LF Energy is providing a neutral environment for collaboration and cross-pollination. So there's not a single company that rules the software or the software project. It's independent and we'll all work together. Open source is also very good for innovation. People can build software and top on somebody else's software. It enables better interoperability, especially if the software is used a lot. And it also allows you to see how the software works, so you can fix things yourself if you want to. It minimizes fragmentation. Hey, why should I build a new tool if there's already a existing one that does the job, and I have complete control over it because it's open. It improves architectures. It lowers the barriers for new companies or people to get involved in a single domain. So, for example, in our domain, it enables new business opportunities. Business can also build on top of existing software and reuse, and therefore lowering the barrier for building new products. That leads to better products, and it also allows to share the cost of the development. So in our case, sometimes what we did in the past was build our own software, but then you end up in a situation where you also have to maintain it, and where you don't benefit from the skill of a diverse community of developers and people contributing to a software project. So what's key in open source is that you have a community around it that all works on the software and help each other out. And then you share the development cost, you share the risk, and you help each other out, which is, I think, is very nice for the energy transition. So in terms of LF Energy project, LF Energy itself is expanding a lot. There are new members, but also a new project. Recently, we added OpenStaff. I put a link in the chat as well. It's not on the page, but it's open source short-term forecasting. We use that in production already in our system operations department. But there's a project about electric vehicles, and there's a project about a gateway for substation automation or automation in general. It's so-called Flash, and the LF Energy decided to make some additions to make that software work for the energy community. We have some grid calculation software. So Jose talked about state estimation, so you could do that using Sochno, for example. And there's also power system blocks is also software where you can calculate grid to load forecast, the other loads, calculating loads, etc. And then we have a project like Grid Exchange Fabric, where you can read out smart meters. operator fabric, where you can see, where you give people a dashboard where they can see what's going on in the grid. CoMPAS is the topic for today. We have an OpenADR implementation, and many more projects and more to come. So if you're interested in one of the projects, feel free to check out the LF Energy website and find out more. In terms of member, we're growing. We have more and more companies saying, hey, this could work, this could help us, we could benefit from it. And so what the LF Energy Foundation does, so the members pay a little bit membership fee, and that helps them with facilitating the open source projects. So legal side, project promotion, and also building community basically. So the LF Energy for now does not do actual development itself, what they do for Linux, but in our case they just facilitate it and organize meetings and so on. And as you can see, more DSOs also from Europe are joining, and also DSOs, and even big companies like Microsoft and GE are now part of the club. And also research and foundations, research and other organizations are interested in this concept, because if you have nice software, it's easy to reuse that for research purposes. And the other way around, if you've made something for research, it could be very valuable for other organizations to put it in production. So back to the substation. If you look at the energy changing landscape, and if you look at the substation, for example, more specific, substations of the future need to cope with all the changes. So one thing we could end up doing is dynamic protection settings for the dynamic line rating. We can move towards more adaptive automation functions, also for incorporating solar, changing parameters of substations during the day, or depending on the plan for tomorrow. It's very important that we have a good understanding of what's get measured and in what quality. And so we need to have insight in that. And it's very important that we have a great insight in all the data, so that we do great data management. So this is the architecture from the LF Energy perspective. So our ideas, and we're working together with a daughter company of Alliander Locomotion, to build a virtual merging unit. So basically a small device where you can measure current or voltages without any intelligence like protections. And then you can send that over 6550 process bus to a central processing system. And for the LF Energy, in the LF Energy portfolio, there's a project so-called LF Energy CoMPAS, and they provide an operating system where you can do such things. And then we're getting to the station bus, and that's where Fletch can come into play. And from Fletch, you can forward the data to your central system. But I also heard that Fletch currently has some features to control stuff as well. So maybe change parameters. And to configure all of this, we're building a tool, an SCT tool, substation configuration tool, based on 6150 and SCL, substation configuration language, and that's the so-called LF Energy CoMPAS project. The goal of the CoMPAS project is to develop an open source component for 6150 implementation for the power industry protection, automation, and control systems. So if you look where 6150 is used these days, you can find it in substation, sometimes a medium voltage substation, maybe low voltage, but now there's also a big trend towards DER. and it's used in hydro and other DER things like wind turbines. And the goal is to facilitate all those use cases to make by making the tool generic enough to do so. Yeah, in terms of requirements we add to the tool, in the long term we want to have also an environment where you can set your requirements. We want to use CoMPAS for grid planning, that we want to convert our grid model to the 6150 model, and I will show you later how we do it. CoMPAS could support in OpenRoles changes. Hey, what's inside the substation? What do we need to change? It could help in the asset management planning. Hey, what do we have? What are the parameters? What's the status? It could help in the data quality, as I said before. Where do we measure things? What's the quality of the measurement? And what are the related settings? Things like deadband. And CoMPAS could be an interface for all the systems. So modern SCADA systems sometimes allow you to import SCL files, so it can help you to configure your central SCADA system. In our case, we also have a configuration management database, and we can provide configurations to them as well, if that makes sense. And for grid control things. From a technical perspective, we set up a so-called microservices architecture. So we don't want to build a big tool and one big bunch of software that all works together, so-called monolith, but we want to separate it all in smaller pieces that can work together, and that's a so-called microservices architecture. The front end is developed together with the OpenSCD project in JavaScript, and the back end is using Java and PostgreSQL. And we're technically also still supporting Basics, which is an XML database. But we had some issues with backing up, so we decided to switch to PostgreSQL. Yeah, so current features of the CoMPAS project, and I will show you soon in the demo. Yeah, you can store and load SCL files. We support versioning of SCL files. The SIM to 6150 conversion is what we support, a single sign-on, because I think it's very needed that you know who's making what changes, since it's pretty mission critical. We did implement role-based access per file type, and all the SCL files are supported, SCD, IID, etc. We allow to display and edit SCL files. There's multi-language support, so let's say you want to have it in Spanish, then you can make that yourself. It's possible. And we provide an IED editor where you can see, hey, what's inside the IED. We can display single lines, diagrams, and we can compare versions. And we're not alone in this. From Alliander, currently 2 developers are working full-time on this developer and 1 business analyst. But there's also contributions from RTE, and they planning to automate the SCD generation process. And we're actively working together with Omicron, which is a big known vendor in the space of testing, and also very big in 6150 testing. And we have some contributions from others as well. For example, Daniel Mullens, he's from New Zealand, and he also sees this as a nice opportunity to bring the 6150 to a higher level. And the part of the development is funded by the Dutch government with some subsidy. In terms of SIM to 6150, this is the workflow we have in place. So you have your you have your connectivity register that spits out the SIM common information model structure of your grid. In this case, to be more precise, the CGMES, Common Grid Model Exchange Specification, and EQ step for equipment, and DL for diagram layout. We did not implement the diagram layout yet, but EQ is there. Then it goes into, then it gets converted into 6150. You can add your own logical nodes to it, bring it to the IAD, and then you can expose your data by looking at the configuration and the real-time data, and then the SCADA system know, oh, at this point this measurement is done, or at this point this function is running there, and then you can take it to your historian. And now it's time for a little demo. Let me see if I can share my screen. Can you guys see my screen?
Yes, so at the moment we can see the Google page refreshing.
And do you see open project window now?
Yes.
Okay, that's good. So this is CoMPAS, and I thought that maybe it would be nice if I can show you the SIM to 6150 conversion. So what I'm now doing is I will load an example file in a different software. This is open source software. We did not contribute to it, but it's we just use it. I made a mistake. Open file. So, and this is the CGMES example file provided by the NSOE. And you can see this is the SIM equivalent of example of the example provided by the NSOE. So you see a substation here, breakers, disconnectors, some transformers, and this is the file we want to convert into 6150 signal line. So I select open from SIM, and I will select the file. And now it's converting. So we need to wait a little bit. And now you can see the same substation in 6150. So you got your base and your bus bars, and they relate to this as well. And what's also nice about the software we built is you can also see the single line diagram. We currently did not upload any diagram specification, so we don't know where to place things. And that's where we use some software of the power system block project of LF Energy, and we can auto-align the substations. I will select some. And now it's on the background, it's trying to figure out what the best position is. And then you end up with this. So you can see here's the transformer, and here are the base of all the substations. So I did not convert that one, this one as well. And the reason why we did this is we want to check if the import is valid, and if there are no strange things in the conversion. And you can also see here the name of the connectivity node and the path name, and you can also see the terminal and how it's called. And by doing so, you can relate back to the SIM files eventually. So this is the import function, and you can use this as a basis to configure your substation. And I will open a different example. Open project. This you can see here all the supported SCL file types. Let me put the training. Yeah, so this is an example substation. It does validation if it's valid. This one has some errors. It's also to show that it validates. And yeah, over here you can see sampled values, goose. You can make communication mappings, and you can change that. And we're expanding those features as well. And this is the latest feature we added, where you can see the configuration of an IED. So you can select one and then look into the specifics of the function. So this GPIO, what the vendor is, what's the software revision, etc. What you also can do is compare functions, so you can save and you can add new versions, project, and then you can set, oh, it's a minor change, a major change. We have history as well, so you can see what has changed. We're using the T history of 6150 for that. But due to time, I think this gives an impression. And I keep it this way. So future development, like I said, RT is busy with the generation of SCDs, so that you don't manually configure 6150 substation, but using the so-called STD, an uninvented CoMPAS specific SCL type, and it stands for substation template definition. So kind of template per bay that you can apply. And the process we have in mind is that there's a process for just getting an SCD, creating an SSD substation, specification definition, loading the substation template definition, and getting the IP addresses. And then it's a matter of an automated process. And this is still in the early days. If you want to know the details, you can see it here in the link. I can provide it in the chat later. Yeah, for the future, the idea is to improve the SIM to 6150 conversion a little bit, adding more and more easy to use sampled values, goose, and reporting blocks, automate the SSD generation, and improve the 6150 validation. We're looking into RISE clips if we can reuse that. We want to support private fields. Sometimes, especially in the case of the virtual merging unit, yeah, there are some fields that needed by the hardware but cannot add it to the 6250. Or that's what we think so far. Maybe time will tell. And we can add 104 support, so that you can, in the SCL file, you can see, hey, this is 6150 and this is 104 protocol. And the idea is also to add Modbus, because some protection relay can communicate over Modbus. If you're interested in learning more, yeah, you can chat with us on the LF Energy Slack channel, hashtag CoMPAS. You can find us on GitHub. That's where the code is. You can subscribe to the mailing list. We're not that active, but sometimes do send an email. And if you like to know more, you can also join the community calls, where you can meet us and ask questions and see where the software is progressing. And obviously, you can also join in the actual development. We do refinements, I think, twice a week. So yeah, there are lots of ways to contribute. You can also contribute to the software code. Besides software code, you can contribute to the documentation, or the promotion, or keeping the wiki up to date. There are making translations. There are many ways to contribute if you're interested. Yeah, so now it's time for the polls and the Q&A, our discussion.
All right, perfect. Thank you very much, Sanders, for your presentation. So I have then the poll questions. So for the time being, I will run the questions, then we can get some answers there, and then we can go into some general questions in the chat. I see there's a question there. So if it's all right, Sander, the first one, I will just ask about the role of 6185 configuration, and then on to the next, and then on LF energy. Would that be fine?
Yeah, sure.
All right.